Okay, this is just a little review problem. Do you remember that this actually has two parts? Y equals that which is a V shape. Did you have that on your paper? Yeah. Good. And then, you don't want to get kicked out. It's not worth it. Then this 7 here, y equals 7, is just a line that goes across like that. Then there are two answers. Would you please circle the spots where they crossed? Hurry up, make the sketch. Unless you haven't got the sketch yet. Okay. And this, I think most people, once they see this, will never forget that there's two answers and one's positive and one's negative. See, that's the classic problem. The reason that we make people sketch this is people go, oh, the answer's 7. No, there's two answers. 7 and negative 7. Okay. Now, how about if it's like this? X minus 3 equals 8. Well, the clump is alone. This part right here is alone. So now I can do that split it into two parts thing. So, do you remember? We split this into two parts. Talk to her later, please. Focus on this. Split that into two parts. Go ahead and write the problem down. There is other places you can be. If you're not here for learning math, then you're going to be going somewhere else for doing something else. All right. So we got two equations. This is pretty easy. It's x minus 3 equals 8 and x minus 3 equals 8. But that'd be just craziness. Don't do the same thing twice. So you put that one as a negative. That's correct. All right. So that bag needs to go off the desk. Sometimes people use that to hide other things like their cell phone or whatever. Okay. So this is going to be plus 3 and plus 3 and plus 3 and plus 3. But then people often somehow think that they're the same answer, but they're not. X equals 8 plus 3 is 11. Raise your hand if you had the 11 answer. Okay, good. Then there's the other side of it. X equals, what's that?
Negative 5.
Negative 5 is correct. All right, negative 8 plus 3 makes negative 5. So the answers are actually quite different. 11 and negative 5 aren't even close to the same thing. Now, I know that these can sometimes be confusing, but if you want to be sure you're right, all you got to do is stick them back in the original. Do you get if I put 11 here, it's supposed to equal 8? And it does, because 11 minus 3 is 8. Absolute value of 8 is 8. What about the negative 5, though? Negative 5 minus 3 makes negative 8. But it becomes positive because those bars make it positive, the absolute value. And it works. Cool. They both work. All right. Now, what we stepped up to next was problems that were like this. And then I reminded you of this dumb little saying, get the clump alone. This is the clump of stuff we got to eventually split up. But we get that clump alone by subtracting 7 from both sides. Do you remember that kind? All right. Give that one a try. And see if you can get both answers without me. I'm going to pause for a second while you try this problem. I got the first step up there. Okay, so here we go. This canceled. 8 minus 7 is 1. This has to be broken in two parts now. Can you do it? That's not the question. We got to write two equations. Equals 1. Kurt, good. Perfect. Yes, keep going. Yes. And now, when I add 3 to both sides, x equals 4 was one of your answers. But if you just get that one, you're going to get half of it wrong every time because you got to be able to write both equations. And that one is 2 is correct.
Yes, I got the answer.
All right. Is there anything about these that, like, if you need me to reiterate any of this, you need me to remind you how this works, let me know. Okay, then, here's the last kind. X over 3 plus 2 in the parentheses equals 4. Now, do you get that this clump here is alone? There's nothing on the outside here or here that we need to get rid of. It's alone. So it's ready to be split into its two equations. So what's underneath here has to be 4 or negative 4. So I'm going to rewrite that. and say x over 3 plus 2 equals 4. It's the exact same thing as the original problem without the bars. We will eventually, but to start with, we just need to write our two equations. What's the other equation? I haven't written yet. It's just like this one, right?
Yeah. Oh, equals -4.
Yes, equals -4. Good. Now, you asked, should we do a -2? You are absolutely right. But after that, you'll have to do one more step. All right, everybody get this far. Catch up. We're almost done with the learning for today. Excellent. Just do it on paper, and I'll call on somebody. I never want to tell ahead of time who I'm calling on, or everybody else quits. I shouldn't say that. Some people will quit if they know I'm not going to call on them. Four minus 2 is 2. That's gone. X over 3 equals 2, and x over 3 equals -6. Those are both negative. They're on the same team, so they just join up, and there's a total of 6 of them, so it's -6. Then, do you know the last step? You multiply by what? 3, like she said, is correct. Times 3 times 3 times 3 times 3. But you know what? If you shouldn't be like picking 50-50 on which one to divide by. You want the x alone, so you're going to get rid of the divide 3, so that's why you times 3. It's not just randomly pick one to multiply by. It's whatever's by the x. So now that's gone. X equals 6. Now that's gone. X equals -18. And if my life depended on it, like every now and then, the real world, your life actually depends on the science involved. A lot of more times, it's a bunch of money depends on it. I'll give you an example. NASA had scientists working on this one problem about getting a satellite to orbit around Mars. And they launched it up there. It got all the way up there. I mean, can you imagine how much work it is to get a satellite all the way to Mars, which is millions of miles away? And it got up there, and because of one little miscalculation, somebody didn't check their work. They oopsed, and they mixed up feet and meters. And that's all it took. And the satellite got too close. Do you know what happens when satellites get too close? They start scraping on the edge of the planet, the atmosphere, and it got hotter and hotter, and then it crashed on Mars. It probably cost well over $1 billion with a B. That's 1,000 millions of dollars because one person messed up the calculation. So my point is, sometimes, like you get a problem wrong, it's no big deal, right? Somebody else gets a problem wrong, it can cost $1 billion. Or it can cost a person's life. Because, like for instance, there's been some recalls of these airbags in cars. Have you heard about how the airbags will like blow up like when they're not supposed to? And it can kill people. And it usually comes down to somebody's calculations were messed up, or somebody used the wrong kind of stuff because, again, they weren't being careful. So being careful can actually cost lives. One that you could actually do, and this one's just kind of along the be careful theme, is if you are ever texting and driving, it is so distracting. You're like, oh, you get this great text from your friend, and you're like, it looks really funny, and you just look down for just a second, and all of a sudden you just piled into some little kid, and he's going to be dead. And you're going to be like, I can't believe I just did that. Because if, all right, so I'm trying to make a point that checking your work is sometimes a good thing. And I get this is just a dumb homework assignment for you. I'm just trying to remind you that in the real world, there are instances where being careful could cost a life. And in your case, I doubt many of you are going to be dependent on to do a math problem that could cause somebody to die. But you are going to be driving a car. And that means you do hold other people's lives in your hands. Because if you screw that up, all you have to do is swerve into an oncoming car and poof, you're probably going to die and so are they. So that's what all it would take. So you got to be really careful, especially with texting and driving. Please, please, just the thing you really should do is turn your phone off. I know some of you will never probably do this because it'll be just like you feel like you miss out too much. But if you just turn the phone off, there's no way you will ever text and drive. It's simple. You can't. You won't get a text and you won't be able to send one. Just keep the phone off in the car. All right. I'm going to give you one more, and then I'm going to walk around, and I'm going to check and see if you did this one right. All right? Last one. And I could use some help on this one. You ready? All right. We're going to start with absolute value of x over 7 plus 1 equals, let me think now. There we go. That'll work nice. Okay. The clump is alone. So now you split it. You got two equations. You solve it. I'll pause for a minute. I'll come around and check you. See if you're getting these right. Recording? Okay. The yellow worksheet, if you're absent. The yellow worksheet here is called Solve Absolute Value Equations, Day 1. And I'm going to do a couple problems and the video's done. So here we go. The first few are really, really easy. I think you can handle all of those. I'm going to have you skip problems 6, 7, 8, 9, and 10. We'll kind of just do a different theme of what to skip today. 6, 7, 8, 9, and 10. Now I'm going to pick up on number 11 and start right there because it doesn't work out super nice and some kids are going to be afraid they're messing it up. Number 11 says absolute value 2x is equal to negative 7. Do you notice something about this one? These are positive makers. There's no solution. You can't make absolute values come out negative. That is never going to happen. You can't have a negative there. So, final answer, no solution. You can't make absolute values come out negative. No solution. Watch for that on your test too. Yep, because you can't have absolute values equaling negatives. Okay, number 12 is a lot like it, but it actually works though, because it's not making you have an absolute value come out negative. So, one thing I wish I would have said, and I don't know, maybe I did at one point, is when you make these two, the equation on the left is the exact equation as you started with, but without the absolute value bars. It's like that and that just go away, and you have x over 3 equals 11. You just copy the original equation, but with no absolute values. And then I think by now you've all caught on to this, that this one's just the same thing except with a negative 11. There we go. It's almost done. Now what are you going to do? Add, subtract, multiply, or divide. Multiply by what? Times by 3, you are correct. Final answer on this one, x equals 33. And over here, x equals negative 33. There we go. There's your two answers for number 12. All right, so this is the part where I give you some time to work on the yellow worksheet, absolute value equations, day 1. And, oh, by the way, if you were out in the hall a minute ago when we did this, I told the kids they could skip. Remind me again, what did it start with? 6? 6, 7, 8, 9, and 10. No, I did not. You are lying now. Okay, that's it.